Hello developers, this video is a success story of creating a super app in React Native here at MPI. We build software for enterprise customers to facilitate their production and quality management, quality control, warehouse management, which made our previous feature-rich app to become slow and bulky and hard to navigate for the end users. So there were two routes we could take. One would be to make a niche small app for every application, for every domain, like one for inventory, one for production, one for quality control and warehouse management, etc. The other route was to make a super app that would house all the mini apps, but we could perform access control to the end user's relevant domain. We have taken the super app route and we never regretted it. In this video, we are going to cover several topics. So what a super app is, you're gonna learn it. If you didn't know, it's gonna be very short. The project structure that's suited us best. I'll show you how we organize the modules and the apps, etc. I will also explain our choice of libraries in React Native that we use for this project. I will show you the tooling that sits behind like the whole project organization and our internal working modules that facilitate creating new mini apps for the super app, and there will be some bonus tips as well. Okay, so let's get down to our first point. What is a super app? A super app is a mobile application that integrates multiple services and features into a single platform, and it offers users a wide range of functionalities within a single app. It aims to provide convenience and streamline various aspects of users' lives by consolidating diverse services and eliminating the need to switch between the multiple applications. And the examples of super apps include like WeChat, Alipay, Grab, Yandex.Go, VK, etc. So why a super app? The first and foremost is dev and user convenience in the experience of how you use the apps. So talking about the dev convenience, when you are working with a React Native project, upgrading a React Native version might be a real pain. So it might take from an hour to a day, especially when you integrate a lot of third-party libraries like React Native Reanimated and React Navigation, etc. So when the next version of React Native is released, sometimes it might be incompatible with the native libraries that you use with React Native. So you'll have to wait until the issues are resolved or resolve issues on your own. And if you have many projects that you have to oversee, because you have many native platforms, right? So every project has its own Android and iOS folder. It means that you have to upgrade every folder. And the problem with that is the time you waste on upgrading just React Native and the libraries grows exponentially. If you are working with a super app, you do that once and for all. Because the SuperApp modules, they are kind of separate from the native modules, so you upgrade the single instance of an app. The next thing is that you have common native dependencies, and all of these common native dependencies are upgraded and managed within a single SuperApp. So for instance, like in our application, we have a scanner module that operates with a scanner software and hardware, and this module has to be upgraded per one app, not for many apps. And if we have if we went for the multiple apps approach, we would have core functionality sometimes tied to native dependencies like login flow as well, handling Bluetooth scanners, scales, and other peripherals. And every change in that core would have propagated to each standalone app. And it seemed and actually appeared to be better to follow the dry approach and the dry principles. So we have a single entry point and a single sign-on. Because like imagine the situation that you offer several services to a client, and each service lies in a different app. So when you're switching between the apps, the user still has to sign on, and you might use the Android or iOS single sign-on functionality, but that takes a lot of infrastructure to be set up before you could go. In a super app, you have a single entry point, like you log in once and you have access to all those apps within your super app. The next one is users with multiple roles would have a handful of apps with dedicated functionality. While in a super app, everything, like all the functionality, lives in the same app, and you have a single shortcut and again a single sign-on experience, like you had set up peripherals once and you could go right away, and all the mini apps would respect that setup. Imagine if you have a couple of apps. Usually what you have, like a client app and a service app for B2B. You might have different roles in that app. For instance, there is the executive officer, and there is some accountant, and there is staff, and you don't want to replicate the same functionality for the core app for the individuals apps, but you want to separate the functionality that they are able to see and interact with. What you do is you just use roles and permissions and turn off some code, and you do not show those apps, and you do not even sometimes load that code for the app when you are using a super app, but you still have one single app for everyone. All right. So we'll talk now about what project structure and what libraries suited us best. We went for Monorepo approach with NX. This is out of scope to talk about NX as a library and what it offers, but we will talk about what it offered us and how it enabled us to scale faster, to organize code better. And NX out of the box gives some good tooling. You need to tweak it a bit to work it for you, but still it's good out of the box very often. So Monorepo gives the tools to facilitate development, like generators and executors. Usually they live in the tools folder, like here, the generators and executors. This is it's not the last version of NX. The next version of NX offers generators to live in the libs folder, but let's not bother ourselves with that yet. It also offered us some publishable supportive libraries and cross-functional dependencies. So that meant sharing code for us. The project structure is the product even structure, the broader one for our company is we have a desktop app that is written with React and Electron, and we have native, the mobile app, the React Native app. And we could share code between those apps. So there were some libraries that we wanted to share. For instance, we shared the hooks and we shared the utils. So we published them to our internal NPM as packages, and we could reuse them between the two projects. All right, so we also have non-publishable components that live in the core. Right here. So these are non-publishable components which we use only in the React Native app. And we also have some GraphQL functions to authenticate and create the Apollo client. We have something that works with the profiles, setting up different profiles for different services and service. And we have scanner modules. So these all go under libs. This Monorepo also includes apps. So these apps go right here, and we will break them down a bit later. Okay, concerning some other extra libraries that we use for development, we use Lingui for internationalization. We're choosing between I18N for React Native, and Lingui and some other libraries, and we went for Lingui and didn't regret it. We use also Shopify ReStyle for styling, and I will talk about that a bit later, maybe in another video. The styling solution that includes switching themes and everything else. So probably there would be a separate video for that as well. We use the GraphQL code again for GraphQL typings. We use Detox for E2E testing, etc. So we'll talk about that in detail, maybe in different videos. What was the most comfortable way to share non-publishable components between the apps, the core? We'll go into the components folder now. Right here, so we have the core, the packages. Now let's talk about the packages. So these core components, and they are quite multiple. They are all not tied to GraphQL. This is very important that you abstract your core components from anything that is tied to data. And that means, since we have GraphQL generated as a build step, you have GraphQL types for the data that that are generated with the functions, and it means that you cannot use those types, you cannot access them, and you shouldn't be able to access them within the libs folder. So everything that goes with the types and is connected to the data lives in the apps folder and not the core folder. All right, then we also use SVG icons. So we use the SVG icons with React Native SVG. I definitely recommend that library. What it helped us is to have no scaling hassle or styling hassle concerning the images that you might have around the native Android apps and iOS apps. And many people even in React Native use images for the icons, and this is definitely what I do not recommend you using. And I do not recommend you using the React Native font icons because the font comes with a bunch of unnecessary data. And this is probably what you don't want to have when you're trying to make your app as slim as possible. And the SVG icons allow you to use only the subset of icons that you want without having the hassle of removing all unnecessary stuff from your font or creating a custom font with only icons you want. It involves some Babel pre-processing for the icons to be converted to the format that your Metro bundler may accept, but this is one-time setup and you're good to go with the icons. Also, we have a single styling solution with Shopify ReStyle for Figma tokens. We use Figma tokens for creating tokens that could be used across multiple apps, and we use the tokens in our mockups. When we have another video for how we use Figma, how we dissect the Figma mockups, how we think about creating an app for the mockups, and implementing the business logic around the mockups, how we find flaws in the design. We will talk about the tokens there as well. You'll see them in practice, how they are used in the components that Figma uses and the designs in Figma we use. And yeah, so these tokens are used for values of colors and fonts and everything. And that gives us consistency in the design, and it gives us consistency in the app. All right, so we also have general theme handling using Shopify ReStyle. And we have a single style dependency. It's going to be in a separate video. We'll show you what we use under the hood, our custom solution for styling. Why we use that? We didn't go for the component library that, like, there are multiple component libraries for React Native, but primarily there are two big ones. And usually what you have is overriding styles of components. That is a definite overhead for a compiler, an overhead for the runtime, and probably there's a big overhead for the size as well. So we didn't want to have that. We wanted to have a lightweight app, and that's why we created our custom components that have definite styling and that support theming. So how we managed to abstract app core, going from lips components, we're going to the apps. So what you can see here in the apps, there is a this MPI mobile is a general, the main app, which has the Android and iOS folders. This is like the core app, the only core that we update, the only React Native app that we update. But also we have MPI shell, which handles authentication, the post-authentication main interface, including the the sidebar, the drawer with the menu. We have service routes over there, like we have settings, service route. This is the thing that should appear on every app, right? But we have a single app, and super apps are just modules. So the settings is a cross module thing. Like you have scanners there, you have scales and everything. Also, this MPI shell app has some data bindings, style bindings, cross-module, common functionality. So just a sneak peek of what that is. All right, this app shell, it can accept routes, messages, the SDK, the module permissions hook, and it gives us the gesture handler, wrapper, the safe area provider, compatibility layer, the dimensions provider, the language, this internationalization by Lingui, the SDK provider, the authentication state machine provider, as well as the progress screen. So these many things, they work here. And yeah, so the toasts. So generally, what would you extract from the app to be available to all the modules? That goes into the shell. What should be accessed by all the modules? That goes into the shell. We also have the common store, like Jotai. We use Jotai in React Native. Why we went for Jotai, it allows us to have async atoms. If you don't know what a Jotai is, go look it up in Google. So basically, this is like a recoil library without the hassle of creating strings for the names of the atoms. So the Jotai atoms, they could be instantiated lazily and only by the modules that use them. If you used Redux in the past, you know how it is, what a difficulty it is to create a store that could be asynchronous, like you add something else to the store lazily. There is a lot of boilerplate around that, and it doesn't work properly sometimes. So Jotai doesn't have that difficulty. And in React Native, if you're thinking in layers, because when you use a stack, for instance, you have layers of things that stack upon each other. Actually, you can think of that as sibling routes. And they have only one common ancestor. And if you are using React navigation, this common ancestor is the navigator by the React navigation library. And that navigator doesn't accept anything but the routes, the navigation routes. So you cannot stick anything like any component or any provider in between. You cannot wrap your routes into a provider, like a context provider. So the only thing you have is to put your provider around the whole app, like the whole navigator. And sometimes this is not what you want. And sometimes it's a bit of a hassle to manage it. And that's why we went for the atoms that could be accessed and instantiated from any component and could be accessed down the tree. It can be actually accessed anywhere, like even the sibling routes, the sibling root routes. because their scope is usually global if you don't limit that. Yeah, so it just works out of the box. And it also handles internationalization, so we have the locales here as well. MPI shell has the provider for internationalization, and the language switching also happens there, and all other modules just inherit the locale and show the appropriate localized strings. All right, let's go to the main app, the MPI mobile. So what does the main app handle? It handles native dependencies. So we have the Android folder and iOS folder. If we use some native libraries for like scanner modules, or we have a native splash screen, not that React Native library, we have our custom native splash screen, so it works as expected, and you don't have problems around integrating some stuff. We also have Storybook switching. You can see the Storybook right here. What we implemented was to have the entry file when we bundle something. It lives in the src folder. Here's the production entry, and we have the main tsx file. So if you look at the production entry, basically what it does, it hooks up the entry, and it registers the main component, the app with this entry wrapped around it. In the main app, we use so we have the Storybook. If the environment variable for Storybook is on, this is where we that's where we use this environment variable like this. So if the Storybook show is true, we show the Storybook in the main app instead of the app code. And if it is false, we show the app. We return the app code. This is the handy toggle for Storybook versus the app. So if you're developing an app and you need to create a component that goes into the library folder, the core, you probably want to develop it not in the app that handles all the data and does the server fetching on every refresh. This is why you should use Storybook. And Storybook for mobile is not that user-friendly or developer-friendly as for the desktop, because you have to run it on a device, and the menu is not so comfortable, but it's better than nothing, right? So we developed this Storybook fetching versus app switching versus app switching, and that helped us a lot in the early stages of development, where you have to create a lot of components, core components that should be extracted from your bundle code. Okay, so the next one is module registration. Okay, we'll go to apps, app TSX. This main app handles module registration. So as I said before, in the apps folder, we have modules. So this is the main app, MPI Mobile, and MPI Shell is a shell app that wraps in the MPI Mobile, which is actually called in the MPI Mobile. And I'll show you this right here. So this is where we show, so this is where we render the app shell. But all other modules, like these 4-letter modules, they are basically these SuperApp mini apps. Okay, they are integrated here, and actually this this main app imports them in the imports. Yeah, so we import them like import the app shell. We import the use register calls. I'll show you what a use register is in a moment. From all these modules, and we integrate them here. So we use the hook that returns the module register thing, and we load all the messages for the apps. We wrap some SDKs that we wanted to have globally. Only for one module, we decided not to go that route anymore with the later modules. And we have the routes, which is actually a callback returning the React node. And we register all those routes. So this is a Boolean from permissions. And if we don't have permissions, we just return null. If the person does not, the user of the app, does not have permissions to access any of the modules, he would see only settings. All right. If he has some permissions for the modules, he would see just those routes, which are returned by the use register in the module. And this is the app shell that accepts the messages, the SDKs, the module permission hooks, and the routes. This is the scaffolding that we use for the module registration in the shell, and the user permissions as well. Why we have this bootstrap of user permissions? Actually, let's look at the module use module permissions file, how we set it up. So there are module names right here that will list them. There is some GraphQL queries that we import from, which were generated by the GraphQL code gen. Okay, let's collapse them. Okay, so what a use module permission is, it's a hook that loads the user, loads some other data from the server, and it has this update permission callback, which defines what happens with the data. So we fetch all the data all at once, side by side, and we set the permissions. Like if you want to have the access to this module, this should happen, right? If you want to have access to this module, these things should happen, right? So these conditions should be met, and that goes for every module. And if the person is authenticated and he was not authenticated, we just update permissions. And if he was not authenticated, he's not authenticated anymore, and he used to be authenticated, we set up initial permissions, and the initial permissions are set all to false. This is how we handle the registration of different permissions. Why we use those permissions in the main app and not the modules? There are actually two reasons for that. This is like the modules should not contain the logic for registering the module. Why? Because later in the life cycle of the app, or development of the app, actually, you have to be able to split the modules away and use lazy loading on demand. And you have to have a very quick resolution whether the module should be loaded or not. And this is why you have to have that in the main app. This is our opinion, and this is what we went for. And this is what really works for us. If you want to lazy load the modules on demand, and you have module permission check right in the module, so you have to first download this thing and then have this check done. And when the check passes, only then you should show the module to the user. But the problem is you don't want to download all the modules to check if the user has permission to view them. This is why we extracted it to the main module. Okay, let's go and see what a module structure is. All right. With this module approach, you can have a standalone development option. What it means? Basically, in the source of the module, you have the index file that exports everything from the use register, and you have the use register file that exports a hook of registering a module that basically is, for us, it's a fragment of one or many root routes that should appear in our sidebar in the drawer. And this is basically it. So it returns the messages and the routes. If you want to, later on, you could copy the iOS folder and Android folder right here and create a scaffolding like in the MPI mobile you saw in the app right here. So you would have another file that does this app shell thing, app shell wrapper, that passes the messages from that hook, the model permissions hook, and the routes. So you would be able to develop that module separately because you have a shell which is wrapping around the whole module and gives you all the necessary functionality with authentication, etc. What it gives you, if you have a separate app which is cloned from the main app, you don't have type checking running for all the modules. So if our SuperApp grows exponentially in modules and we add like another, I don't know, 10 modules to the app, that could slow down the compiler. That gives a definite load on a TS compiler. We use TypeScript and many other things. So if you want to have a robust development environment and you want to work on a separate module, you could have a standalone module right there set up, and it would be set up only for development, and for production it would use the registration in the main module. This is an option that we didn't use yet because we were not pressed into using that. Everything is running smoothly so far with 5 modules, and which are quite bulky actually. Registering the module is done again by providing the routes, which would be injected into the main navigation right here. We also have locales here. So every module we decided should have his own locale management. When you use locales, there's this messages by locale which import, which actually export everything from these 2 folders, and the more languages you have, you will have more folders right here with the message files. So yeah, and these what they look like, the strings as IDs, and the strings as their translations. In the latest Lingui release, you don't have to specify the strings for the IDs if you want to have valid identifiers, because they replaced them with auto-generated identifiers in production, which we will use a bit later when we upgrade to the latest Lingui. Okay, so what we also have here are machines. What machines are? They are finite state machines. We use xstate for creating those machines, and they are a great deal for React Native projects. Really, they saved us so much time debugging the application, because your application, when it grows in logic, it may have so many if statements and everything, and when you open that file with a lot of code, a lot of business logic, and you look at it, it's very difficult to decipher straight away. With xstate, you have a graphical representation not only for creating the business logic, but also for reading it back when the whole module is implemented and maybe not implemented by you, and you don't know how it works. When you look at the state chart, it's really easy to understand what it looks like. Okay, let me show you this. Let me show what the visual editor for xstate chart is. So you have the edit. You can edit the state chart that shows you what exactly happens in your app, and you could also stop. All right, you could also simulate it right here. So if your app is in idle state, on entry it resets its context, and yeah, let me zoom in. Come on. Yep. So when the QR code is scanned and it is item like QR, you're going to the get item function, which invokes some asynchronous function. On error, it goes into idle and shows the failure toast. Okay. On done, it sets the compound ID and goes to editing item quantity. You could cancel from here and go into idle. You could submit from here, etc., etc., etc. So it makes understanding of the business logic so simple. We went for xstate and we never regretted that thing. Where xstate is useful, and to break it down simply, is when you have some states of the app or of the component or of the business logic that you could iterate. For instance, if you have an interface which is usually a single page and you have, I don't know, a table, probably you don't need a state management for that. But when there is a user flow, how the user travels through your app and through the screens, this is what usually happens in mobile apps. To maintain that user flow, you could usually use a state machine like xstate. Offers you it's a JavaScript library that works well with React Native project. Yeah, so you could maintain that logic within a single screen or across multiple screens, and it works like a breeze. It makes your code simple to read. All right, we also have, we have state machines. We have navigation here. This navigation hooks into the navigation module of the shell, which handles the cross module navigation functionality. So the shell has the drawer and we hook into that drawer and we display routes for the drawer items right there. So this is where we register for the drawer, and these are the types for our navigation, so we know what we're working with. And these are the types for this module, like these props and params list and different, like the screens. Yeah, so we have no props for the quant list, and we have these props for the edit inventory and the navigation itself. Right, so this is the navigation for the module. So we have this screen options and the routes that we display in this navigator. So we use a stack navigator for the module, and we use stack screens, and we have a drawer navigator for the whole app, and we integrate those stack screens. Basically what you're looking at is a physical inventory navigation, which is a root drawers navigator screen. Right, so this is how we integrate into the drawer. And we have in this stack navigator, we have different routes. For instance, for this module, we have two routes: this physical inventory screen and quant list and the edit inventory. Two routes that accept the component which renders this route and the options for the screen, the default options that it opens with. Besides navigation, we have the screens folder here, which actually lists those two screens for the route. This is the folder structure that suited us best. And in the screen, what you can see is the index file that exports the screen. The quant list, we do not use default exports. It is generally a bad practice. You can read on the internet why it is a bad practice. And we use named exports everywhere. Generally, you should use default exports only if you are exporting a lazy loaded component for React Lazy. In other cases, you want to go with a named export. Okay, so yeah, so this is the screen which has all these types from the type file. And we use the styling solution here that we created, the use styles, which gives us the classes. We use the theme sometimes, like a standalone hook. Usually you use the theme only in the styles. The local theme, yeah, we have separation for the global theme and the local theme. And we have this machine. You see this machine in action. So we have the state of the machine and send and the instance and everything. And yeah, so this is basically the general React component that you would see. Let me scroll to it. Yeah, so this is just a React component that gives you the functionality for this screen, nothing fancy. Okay, so this is like the main component. We also have this internal folder. Let me close this. The internal folder where we put everything that should not be in the root. These are the internal components used by the main file, the quant list, which actually, as you can see, corresponds to the directory name. It's the same one. And in the root, we have only the files that we want to share across the screens. So for instance, if edit inventory is accessing the use handle QR or the atoms, it should go into the root of the folder. If the files that are used in this screen should not be accessible to everyone around outside of this directory, they go into the internal. This is the convention that we employed. And this folder contains all the GraphQL files that we use with the GraphQL CodeGen. So basically, it's the CodeGen creates a folder that's called SDK. You can call it anything else. This is what you set up first, and it creates the types for your GraphQL based on the schema you have. And this is how you declare your GraphQL. This is what you import from that SDK generated, and this is the template literal string you use for defining your GraphQL code, and you export the document, which is a typed document in this case, which gives you the possibility of strict type checking what you require from that GraphQL mutation or query. So yeah, you have the folder. This folder, as you can see, is local to the screen, so it contains only the files with the functions that are used in this screen only, and they should be unique with the names of these functions. Should be unique across the module, not the whole app, only the module, because every module has its own SDK, which is generated for the module alone. Thus, when you have like two modules, you have two SDKs, and each module uses only its own SDK, and that gives you the separation of concerns, and it does not load a lot of functions into the scope unless you lazily instantiate that code for the module. And we have the SDK, as I said, so these two files are automatically generated by the CodeGen, and it creates the GraphQL TS file, which has all the types of our API, GraphQL API, and this GQLTS is basically the documents that it created with the CodeGen, and it has the code actually of the GraphQL fragment that you wrote right there, or GraphQL query. Okay, and the index file just exports everything from GraphQL. If you want to look what the GraphQL CodeGen looks like for us, okay, so basically we have this schema that we define in the libs GraphQL generated. We generated with an X generator that we created ourselves. because our schema requires authentication to be grabbed. So it takes all the TypeScript documents from the SRC folder, and it does not take anything from the SDK folder as you saw before, because those are auto-generated, you don't want them. And it generates into the SRC SDK folder with a client preset. This is the version 3.0, I guess. That's the name of the version for the autogen. And so this is the preset config, the strict scalars, blah blah blah, naming convention, skipping type name and everything. We override this file and we ignore no documents. This is when you don't have GraphQL documents and you have the setup for auto-generating. It does not error and lets it pass. So this is the GraphQL RC file. You see there is no hassle for the setup. Basically, you have the GraphQL files in the screens folder like this, and it fetches all these GraphQL types, GraphQL documents, generates them for the SDK, and then we import them from the SDK into our project and use the functions. As simple as that. The atoms, what are they? These are the Jotai atoms that I spoke of before. Yeah, so we use the atoms, like, let me see what the atom is. Yeah, so this is the atom that accepts a map of a string, for instance, or undefined, and we can set it up lazily. This is a function that parses the atom data. So these atoms are generally a store that you want to access. If you went from the Redux field, the store that you want to access lazily, you just call use atom value and accept the value from there, or you set the value if you use the hook use atom. Okay, this is about the screens. So in this mentor's time today, we are going to cover a very important topic, the value of a developer and ways to cut costs without sacrificing quality for the product. So let's get down to it and understand what a value is first. So the value is what you may offer for the money you're paid. This is the basic description of what a value is for a developer, because when you are employed at a certain job, you are paid the money for doing the work your boss cannot do or does not want to do, right? So you offer him the value of your expertise, of your skills, and you are giving the equivalent of your value in money. So the value like of junior developers and senior developers is different, as you have seen from their check. Even though they push the same kind of quality code into the master branch, they are paying differently. Why? For the expertise. So the junior developer does not have the expertise of a senior developer, even though their code may be similar. Maybe even the junior developer or the pushes a lot often than the senior developer to master branch and writes more code, but it doesn't make him more valuable. So what is value actually? So let's break it down into the parts that we may understand and control. So the value is the ability to achieve the desired goal divided by the time you spend on getting things done. So just imagine there is a task that is given to you, for instance, to create a module or a component, reusable component, and it takes you some amount of time, right? So the senior developer can get this job done a lot faster and a lot more efficient than a junior developer. So what you need to increase your value is to learn how to get things done faster by iterating less on the problem and by increasing your efficiency. All right, this is what increases your value and it increases your paycheck. So let's talk about how to cut costs. The costs for the company and the costs for you eventually. If you cut costs for the company, that increases your value and increases your check. So you need to reduce time to do things by planning in advance. This is very important. Many people, like especially junior developers, they fail to plan. And by failing to plan, they're planning to fail. So that what takes them a lot of iterations on the software they're building, on the things they're doing. When you make the right architectural decision in advance, when you think it through, and I'm going to show how I'm doing this in my company when I'm tackling design in the following videos. Just before implementing it, you have to think through the whole process of the user onboarding, of how other pieces and parts of your application and infrastructure work together. If you make the planning done, you are subscribing yourself to a success rather than a failure, and it saves you a lot of time in the process. The second thing that would save you a lot of time coding is mastering the tools that facilitate doing your job faster. For instance, if you need to use neural networks for tedious tasks, then do that. You have like a Codium for VS Code as of today. You have ChatGPT. It's not to replace you, rather than it's to facilitate you doing the job faster. For instance, if you understand what this function should do, and it's quite separate from the concerns of the whole project, you extract the idea to a separate function. You may ask the neural network to do the typing for you, and you assess how it is done. You ask it to correct it or just correct it manually. But the thing you should do is to eliminate the necessity of typing too much, because the junior developers, they love to type. And the older you grow, like you become a senior, you don't like typing, right? So you try to reuse code rather than repeat yourself. You try to use libraries rather than creating it from scratch. So you, of course, you try to think in advance what roadblocks you're going to face if you do this and that, and that helps you a lot. As well, like there are a lot of menus in your VS Code, for instance, or your IDE that you're using. If you learn to use shortcuts, you're learning how to not waste time on things that do not matter, this clicking and mouse and everything. So you need to learn and to be an expert of what you're doing in the field that you're doing. And the third tip for cutting the costs and cutting the time is to grow yourselves by reading more in your field and in the adjacent fields. I call it shallow reading. Like if you are subscribed to a Medium site or any other place you're drawing your knowledge from, you need to be aware of things happening in your domain and the adjacent domains, so that when a problem comes, you have a shallow knowledge of something, and you can go deeper and dive deeper into that topic when it's necessary. But you know that this problem has been solved by someone else, and you know of the problem. That gives you the opportunity of not thinking your way through or inventing or reinventing actually the wheel. You know that this problem has been tackled by some other developer or a company. You go look up their solution and you adjust it for the needs of your company. This is how you do this faster. So once again, to recap, your value is the ability to achieve things very fast, okay? To go to the desired goal of your project manager or your own goal faster than usual. And if you grow yourselves, you will grow in value as well. If you make yourselves irreplaceable, that will make you irreplaceable. There are a lot of coders, a lot of developers that can type, that can use the language, they know the syntax, they know different architectural approaches, etc. They know how the database is structured. So what makes you different? your expertise in different fields and your breadth of thinking, your ability to plan, ability to take right architectural decisions rather than knowing different coding approaches, that what makes you irreplaceable. Okay, and if you are staying with a company long enough, make sure that you grow rather than staying on the bare minimum not to be fired. And now it's time for the bonus tip. As you saw before, we have app folders, which are like modules or mini apps for the super app, and that's a bit of a setup, right? So you have a lot of config files, the GraphQL RC, the setup for the locales, for the machines or navigation, the screens, the SDK, and all that. It's quite tedious to copy and paste that to generate a new module. And if you want to create a new module, just imagine copying an existing folder, removing all the extra file from the previous module that usually gets dragged around. So what we created for that is an NX generator. And I could show you the tooling now for how NX enables you to generate modules, like whole modules, in a couple of clicks. So let's see, we have tools folder and generators here, and we have a generator for an app module here and a template. The template creates the screens, like the drawer screen or the track screen or a component, and the app module, come on, close it. The app module has a module template. So basically what you saw in this module, let's open this module now. All these root files are here in the template, as well as the SRC folder, which contains the locales, messages by locale, which contains the navigation, the setup for the drawer, to inject the types into the drawer and have the types which are commonly inherited from the shell. You remember we had the settings routes, which actually just a name of a root route, but settings has a lot of other routes. This is the common navigation types that we inject down the tree into the module. So it has knowledge of the direct parents and siblings, and it has no notion of the sibling modules. This is what we set up in the drawer template, the navigation types template and the types template as well. And we have this SDK template, the use register template, everything. Okay, so we go for the NX console. Can you imagine that? So NX gives you a console for your projects as a VS Code extension. This is so handy. In the past, we used to write all the commands in the console. Now you have the user interface for that. So yeah, this is how it looks actually. We have all our apps listed here. We have all the libraries listed here. And we don't often use package.json for any scripts, because all the scripts that you need can be in this NX file. Just look at that. And you can run them from here. You can jump to source and see how it's implemented. This is like the main app, so it has a lot of functions right there. This is the module. It has a lot less scripts running there. So if we need to type check a module or to generate GraphQL from the GraphQL files we created for the module, we use this function. We test it or lint it like this. So but to generate something, come on, yep, we press generate, and it's somewhere at the bottom of the file. We generate the app module. We just specify the module name. So as you can see, we have modules like these 4-letter names. Let's create a module with 4 letters, TEST. It creates a dry run. What a dry run is, it executes the script, but it does not create any files. What it would do, it would create all the folder in the apps and all those project files that are necessary to set up the project. And it would also update the workspace JSON, which contains the information about the modules for the NX. It would update the tsconfig base JSON, which has the information of how to use short links for the module. For instance, you could have seen, let me show you. Yep, this MPI Cloud Core is the shorthand for the libraries core packages, src packages button. Okay, so this MPI Cloud Core is a shorthand import, and when we have the module imports inside the module, we use the tilde thing, just like this. So this is the import for the files local to the src root, like the machines folder. So it's actually accessing these machines folder in the src folder, and it has the cycling machine right here. This is what it does. And to see what the file looks like, let me show you. This is the workspace JSON, has the listing of all the modules, all the projects, and you can go to their configuration. This is what is inserted by the NX. And yeah, so these are the libraries, as you can see by the name of the directory libs, and the apps as well right here. So this is where it inserts the new app that we are going to create. And the project JSON, it has all the tooling, all the functions. Like you have the publish action, it creates the NX executor with the run command, and some options to publish this library with, or the build, etc. So this is the replacement of your package JSON scripts, which might be a very long list, so you cannot even see your dependencies. So let's generate the new app module with the name test. We press generate. You should open the console and perform the generation, not the dry run, but the no interactive generation of the module. So what it has created now is a generated JSON for the tools, and very soon it's going to create the files, update the workspace JSON to insert a new line, the tsconfig base JSON, the Lingui file that states the language, and the new folder to look up the language strings, and it is going to update the ESLint RC. I'll show you what it does in a moment. Actually, it's a good nifty feature by NX, which enables you to state which project your module may access. For instance, if you don't want to have modules accessing files from another module, and you have ESLint checking for that, you would update your ESLint RC file with that configuration, and you would restrict, for instance, the module visibility for the module to see only the shell and the libraries, right? And the shell may see all the modules because it has to import them. This is how you control that you do not accidentally import something from a module the user does not have permission to. It creates the use module, updates the use module permissions of the global app that integrates all the modules and handles the permissions, and it updates the app TSX. So as you can see in the changes, we have 23 files generated. You didn't have to generate them by hand. We'll just take a look at the folder structure. So in the apps, we have this test created, the locales, the navigation, the SDK, the drawer right here, the basic typing. So what you cannot see here is the screens folder, and this is what we use, and this use register as well, it does not export anything from here yet. We generate a template. So in this template generator, we should specify the file name. Here it's going to be a screen because we want to generate for the project named test. Okay, we want to not a component but a drawer screen. And the name of the screen is gonna be... Alright, so in this generate UI, I have created the screen for the project name test that we have just created with the type of drawer screen. So we have a selection here, component, a drawer screen, a stack screen, and the projects list all the projects that we have in our Monorepo. So this the drawer screen root names are comma separated lists of root names to add to the drawer screen in case type is the drawer screen. So type is the drawer screen here, and we add all these screens, a screen number, just to see how it works with a camel casing, number 3. All right, so the stack name that these screens are going to be added to is my super test stack. What we are doing here, we are creating one root route for the drawer. Okay, it's going to be one menu item in the drawer, my super test. Okay, let's give it a 1. For instance, my super test 1 stack, and it's going to create one menu item. And in this root, we're creating a single stack with 3 screens in it. Screen number 1, screen number 2, and screen number 3. These are going to be stack screens in a stack navigator. So we press generate. All right, so it has created the 3 screens for us: screen 1, screen 2, and screen 3. So there is screen 1, screen 2, and screen 3, and it camel cased the screens. So let's see the folder structure now. Yep. So now we have the screens folder, screen 2 and screen 3. Each one has an index file, and screen 1, let's see what it looks like. Okay, so you have the screen wrapper. It's a custom component that we created for the screen with the styles. It has a refresh control, blah blah blah, the overlay that gives you the screen title. It has the styling solution, a boilerplate implemented here and using classes here, the use styles. It also has the screen options ready with a default presentation for the stack with the back button, custom back button, the header title, everything. All right, so this is the boilerplate that we didn't spend much time creating. It was not made by hand. It was all automatic. So now we have 32 files. The folder structure. So in MPI Mobile, what happened? So we had this app tier 6. It automatically imported the use register from MPI Cloud Test. This is the module we created. The test, use test. So you see this insert module hook. It inserted a new hook here. Insert module messages. It inserted the messages for Lingui. So what else happened? Okay, yeah, these are the dependencies. It also inserted the permissions right here, and it inserted the routes. So all this was done automatically. And we have this 30 files created for the project with the screens. And if you look at this navigation, as you remember, when we created just a module, it had nothing here. Now it created a navigator screen 1 as the initial route name, but my super test 1 stack was the name of the stack we created. the screen 1, screen 2, and screen 3. These are the screen, the stack screens were created for one entry in the list of module routes. Okay, if you want to create another module, you would generate another module the same way, or if you want to create another a drawer entry, you would do the same thing again. Okay, let me revert the changes, discard all the 30 files. I'll show you what the generator looks like for the module. So the template, you saw the module, app module. Now let's look at the template. Basically, a generator, you can read about it in NX. It consists of schema. So there is the schema you define. Let's look at the TypeScript schema. So there is a project name, file name, stack name, use styles, type, char, screen, root names. That's all you saw there. And you create a schema JSON where you define these properties so that they are accessible. And this is like the schema, the JSON file that NX uses to populate the UI for you. And all these properties, like the project name, its type, screen, a string, the description, the name of the project to add component to. If you want to correlate them, I'll just show you the template generator right here in the UI. So this is the description, the name of the project to add the component to. It has the default source of the project name. These are internal variables for NX to understand that we are accessing project names. This is how you have this drop down within names of the project. And the new generated project test was added here, and now it is removed because we discarded all the files. Okay, so the file name, you can have lists, checkboxes, everything. So the string, boolean, for instance, use styles is a checkbox with a description and a default of false. If we expand all options, we have this toggle for the component to use styles or not. All right, so this is a schema JSON, and you have this the templates that we used for the drawer screen. You saw, so they are all generated from this file, the drawer screen, and they create some stack screens as well. So these are the names of the files that are going to be used. And this is the ESM, right? No, not the ESM. What's the name of that module again? EGS. Yeah, there's a lot of things starting with E. So this is the EGS notation, like 4 const root names of drawer screen root names. These are the variables that we pass into this template. I do the looping to create the imports of the screen title and import of the screen options, and I also import the types and all this template, the EGS template. You can look it through now. It's quite easy to understand. So these are the screen options that we do create here for the properties. Also, there is this stack navigator with the initial root name, and we loop through the routes for the stack navigator right here. And this is the screen title and the screen options created here. So this is what the template looks like. And this is the code running the template. It's not quite long. So what we input here is the dev kit, the tree for my files, generate files, get projects and names. We also import path and interface schema from the schema file we had created. You remember this schema TS file, the interface schema. So the export default async function is actually the function that is run in the generator. And you have it in the index.ts file, so the NX console knows where to take it. So we take the projects, all the projects from our host, the tree that is given to this function, and we get the schema project name. Schema project name is the name of the property. You remember we wrote test there. That's get test from the projects. This is the name of the project. It's going to be a project configuration. Here we define the target path, where to put those files, if the file name and type. Yep. So the screens, the packages, or the libs core. So depending on the type of project source root, if it starts with libs, if we're creating a library component, not an app screen, it goes into the libraries. If we create a drawer screen, the target path would be navigation, because we want to put this template into the navigation. Otherwise, we would put that into the packages if it goes into the libs core, if we are creating a core component. Okay, so the target path here, and so the template names. Names is an utility function from NRWL dev kit. NRWL stands for NX as well. That's the narwhal, I guess that's how you pronounce it. That thing, where is it? That thing allows us create a file, actually an object with the names of the file in different cases. So this is the basic name that you gave it, the class name, the property name, constant name, and the file name. So if you define different writings for the same thing, if you want to have like a camel case or upper camel case, or you want to have a snake case names, it all depends on how you name things in your project. So we get here this template names object that we are going to pass to the template and use it there. Later you have this drawer screen route names. You remember that property, the comma separated list of routes that you are going to use in your stack. Over here we split them, and we have the list of drawer screen route names. And then you have this screen config, the TMPL. It's useful for removing this TMPL from file endings. Why would you have it? You would have it for your ESLint not checking these things and your preacher not parsing them. Just went for this suffix. Okay, the file name. The file name would be the template name's name. Okay, the project name, stack name, use styles. These are the variables you're sending to your template. And then we call this generate files that takes the host, the template path, target path, and screen config. And then I just massage the strings in the created files. I replace them with the things I need. Yeah, so these are the types file content. We're creating the types for the navigators here, like the root drawer params list, and then the name of the stack params list for each file. For each screen you want to have a params list. Then the screen props for that thing, screen navigator. So everything that goes into the types file in navigation that you saw before is automatically generated. And then you want to the use register content. You remember that use register file that we spoke of before? It all creates here, like the imports. It injects the imports and replaces the this import with the screen config file name navigation, and the empty fragment that was created in the module generator we replace with the drawer screen, and like everything else. Yeah, so we generate screens for the created root stack, and that's it. So, and then at the bottom we format files so that we have the pre-tier and ESLint run on them. And that's it. Basically, this is how we generate the files. Okay, the second tip The second tip would be how to organize the local references to module files by annex, and to limit their visibility that I spoke before. So first off, we are going to tsconfig base JSON. This is where it is defined. In the compiler options, you have this paths. So we have a global name, the MPI Cloud Core asterisk. It goes for the libs core src packages and libs core src packages asterisk index.ts. What it enables us is to import the packages from the root, as well as import files from the package file. For instance, we have a button, and in the button we have some hook file, and we want to import that hook that is exported by the index.ts. Second one is the locales. Yeah, we may import the locales. The GraphQL, as you can see, this is a publishable library, and when you publish something, or you have to generate or bundle the code first, and it ends up in the dist folder. So that the TypeScript does not go nuts, we have to import from the dist folder as well as the libs folder index.ts file. This is just for the compiler. Okay, these are the global imports. They start with an @MPI Cloud /shell, for instance, or scanner. These are the local imports that are used only in the project. They start with a tilde, and we have the global name matcher that matches to the apps, the name of the folder, the name of the app, src, and asterisk. So that enables us within the project, within, for instance, WMCT, to import from the src folder, like from the root of this folder, and using global imports instead of local imports within the module code. The next thing we want to look at is the project JSON within an app. So let's go to our WMPI, the project JSON. So here you have the name of this project, and you have the source root of the project specified here. And a look at the tags. So this is a project type of application, and these are the tags that we use to specify what exactly you may access. So you may access this module has tags app module, and it has a tag of WMPI, the name of the module. If we go to the apps WMPI src ESLint, you want to look at this overrides of the ESLint that's called NRL enforce module boundaries. Usually it gives an error, but it allows, using the WMPI, the local import that we have with the tilde, prefixed with the tilde. We also may import from the shell, from inside this module, and we may import from the shared. The thing is that by default, NX bans importing from outside the module. You have to be explicit, right? But here we override these imports to allow ourselves to import from the root of the module. Okay, and this is basically it, what you need for a setup. And if we go to the shell, MPI shell, the JSON file, the ESLint, so it allows the shell and the shared, right? But in the main file, main app, you are allowed to import from all the projects, right? And it is automatically updated when the generator is used. So you insert a new project here at the beginning of this allow list, or at the end, it doesn't really matter. And you have you have access, because all you need to is scaffold and import the projects, import their user register and everything. So it happens here. So this is it. This is how you organize the local importing in your NX project. So as you have seen, we have managed to create a super app with the following project structure that we showed and some bonus tips. Make sure you press like and subscribe to our channel, because we're going to be releasing more videos about state machines, how to create state machine, and even videos of development process and thinking process. This is what we are going to transfer to you as the knowledge. Many companies share code, like open source their code, and we're going to open source our thinking about the code, thinking about structuring the project, or thinking about different patterns of how you develop software, of architectural patterns, etc. So make sure you stay tuned with us and have some coding.